Hello everyone. This is my first video. I know there's a lot of tutorials already out there, very good tutorials about STM32 microcontrollers, but uh, maybe this or my videos could be useful for some of you out there, and maybe with a different approach or a different explanation for a topic that uh, it's already been explained, but maybe in a different way. For some time, I've been wanting to create a custom board, like a system on module that I could easily install on different carrier boards according or depending on the functionality that I wanted to test. And but I wanted something that I could easily install and remove and use in different projects. So I came across with the idea, or I took the idea from one of the videos of Phil's lab. Is probably you know his videos because he's very popular in YouTube, and I came across with this with his design of a system on module using the form factor of M. Well, not the M.2 is the connector, but the form factor of SSD drive, which uses this M.2 connector. So I thought it was a great idea. It can be easily installed and removed from different carrier boards or motherboards, if you want to call it like that. And so I took that idea. My design is similar to his, but not exactly the same. I have the microcontroller and the flash memory. He also have here external RAM memory. I didn't add that to my design. Just the flash memory. It might not be exactly the same flash, and certainly the microcontroller is different, but the concept is very similar. So I based my design on the STM32L443 microcontroller. I have a 128 megabits flash memory, external memory. I just have a reference voltage, the boot selector for the microcontroller, some external crystal oscillators, high speed and low speed, my connector for my debugger, programmer and user LED, and also a power indicator, LED indicator, and my M.2 connector. This is a type B connector, and this is not following any standard M.2 pin out of the connector. This is totally defined by me. What I at the moment was easier for me to route in the PCB. So this cannot be connected on any motherboard, and it would work. This pinout is totally defined by me at the moment I was routing the PCB. So the design, as you can see, is not very complex. There are just few components on the board, and this is how the PCB design looks. I made a few mistakes in this first version. I already corrected some of them, but the board is it's been working okay. And this is how the board looks on the 3D view. As you can see, it's a well, it might not look small, but it's a small board. I can show you here some details of the board. It is a zero point 0.8, approximately 0.8 millimeters thick, because that's the maximum thickness that the M.2 connector can handle. And it's a 4-layer design, 30 by 42 millimeters. Um, I forgot to mention that my intention here is not to teach you how to design the board. It's just a walkthrough of the more overall design. And in the later videos, I'm gonna start like playing a little bit with some of the peripherals, flash memory, the SPI, UART, and USB, and any other peripherals that you want to see, or the ones that I have here implemented in the board. So the board itself is not like very useful, I would say, because there are now many things on the board that we can use. Maybe we just have the user LED and the flash memory that we can write or read from the memory, and flash or use a PWM channel with the user LED. But other than that, the intention of this board or the design is to be installed in a on a carrier board where all the functionality is going to be. And to test all of these, or the peripherals, I designed a carrier board. This the block diagram and how it is structured. So I have my power or power supply, I have the connectors and all the interfaces. And in the interfaces, I decided to put a CAN bus, RS485, some LEDs. I have 3 LEDs. They are connected to a timer channel, so we can generate PWM signals. I have a power indicator, some potentiometers that we can use to test the ADCs on the board, and also have RS485 and CAN bus. Of course, I also have the other standard peripheral interfaces like I2C. I have the SPI, UART, CAN bus, I already mentioned it, and a master clock output just to test the output, the frequency produced by the microcontroller. And here I have the M.2 connectors, so type B, as I said before. And here there's a 3D view of the carrier board. So just unselect this. So here you can see I have the two potentiometers to test the ADCs, SPI interface. Here we have RS485 interface. This is the RS485 transceiver. I have here the USB, UART, I2C interface, and the CAN bus interface, and the 3 LEDs here on top. This is the CAN bus transceiver, and here a jumper selector to have to select or not the termination for the CAN bus. And so that's basically the design. of this of this board, and here we have the M.2 connector. So this is the first version of this board, and and uh, the system on module board. So in the next version, I was thinking to I haven't designed the second version or created the second version, but for the next version, I'm going to use, instead of the M.2 connector, uh, I want to use a PCI Express or micro SATA or SATA. I'm not really sure how to pronounce it. Um, but the problem I would say with these is the pitch of the M.2 connector is very small. So here it might look there's enough space, but this is a 0.5 millimeter pitch, so that's very small. I soldered this using a hot plate, and still I got some jumpers that I have, like some bridges between two pins that I have, or I had to manually correct, and this is a tedious process and is very small. So for the next version, I was thinking on using, instead of the M.2 connector, using the PCI Express connector, which it's a little bit bigger, so it might be a little bit easier to handle, especially the soldering process. So this is a 0.8 millimeters, so you can see it's very affordable, it's not expensive. And here in Mouser Electronics, we have plenty of them, and it's less than $1. So it's a affordable connector. And here we have all the specifications for the connector. And well, this is the microcontroller. As you can see, the microcontroller is not very expensive as well. That's one of the reasons why I chose that one. And here I have, or we have, more information about the PCI Express connector. And I'm not interested in the full on the form factor of this Express mini card, just the board edge connector. And but here we have some more details. Maybe this form factor of the board is more suitable, but if I will decide that when the time comes. So for now, that's all. This a very broad overview of the design of this custom board, and I will be publishing another videos using the all the peripheral interfaces. Probably I'm gonna start with UART, which is very simple, and using maybe the LEDs, so to guide our use our Hello World interface application, which is basically blinking an LED, and also how to program also the board using the USB, just to test that the USB interface is actually working. And and then subsequent videos, I will be publishing more or creating other testing other interfaces, like I2C, SPI. The flash memory is also one of the targets that I want to test, because it's already mounted here on the PCB, and the same board, on the system on module board. And CAN bus is also something that I've been working on. and I already tested this interface. It works, and probably that's also one of the first videos I'm gonna publish is gonna be how to use or a project using Canvas, because I don't want to create just a video transmitting some uh, meaningless information through the Canvas. Maybe uh, the it is more useful to implement something that some of you might need in some of your projects. All right, so I hope to that you can have something from this video, and let me know in the comments if you want to see something in particular and on the next video. And thank you for watching, and I'll see you in the next videos.